Okay, guys, so for today's thing, a couple things. One, you might want to start with a nice, fresh, brand new piece of paper, because if you've only got this much left, it's not going to be enough room. So I'd recommend starting on a brand new sheet of paper. 2, make sure you kind of label or highlight kind of each step. If you want to put numbers, that's fine. And make sure you kind of write small enough so you can see what's going on. 3, you're going to want those nice little flip charts that we made in the video previous. If you don't have your flip chart and you're trying to watch this video, you need to stop and go back and make one, or else you are going to be so lost when it comes to doing your homework today. So if you have done all of those 3 things, let's go ahead and proceed. So with these problems, we're trying to take this complex problem and we're going to graph it to the best of our ability based on all the different things we know about first derivatives, second derivatives, x-intercepts, y-intercepts, vertical asymptotes, horizontal asymptotes, critical points, and points of inflection. So using all of these things, we're going to go ahead and take this problem and we're going to graph it. So when we do these, the first steps to do is take the first derivative. Now, that top looks a little busy some to me, so I'm going to simplify it by multiplying that 2 in. So all I did was I simplified the top for myself because I don't want a difficult top. So again, first steps first, take the first derivative. So we have low, d high, minus high, d low, all over low squared, and like normal, we know not like normal. Looking forward, we see we're going to take the second derivative, so we're going to simplify this guy a little bit, which gives me 4x cubed minus 16 minus 4x cubed plus 36x. Oops, my 16 needs an x, I apologize. Which will simplify finally to 20x over x squared minus 4 quantity squared. First step, take the first derivative and simplify. Second step, take the second derivative. So I have low derivative of top minus the top derivative of the bottom, which is chain rule, all over that bottom squared. And remember, it's already squared, so it takes it to the 4th. Now, we just recently talked about how we have a factor of x squared minus 4 in each of my 3 pieces. The first part on the top, first part on the bottom, and the big bottom. So because of that, this guy goes away, this is no longer squared, and this is no longer to the 4th. So we're going to go ahead and multiply this stuff through. So I have 20x squared minus 80. 2x times 2 will give me a 4x, and that 4x will get multiplied by a negative 20x to give me a negative 80x squared. All over x squared minus 4 cubed. And then when I simplify that one more thing, that gives me a negative 60x squared minus 80. So, if you notice, we're almost all the way through before I can hit my X on the page. That's how long these problems are, and we're only on step 2. We can do it. You just need to make sure you give yourself enough space. And I know my face is over here someplace, so I need to extend a little bit. Step number 3 is my x-intercept. Now think about a graph for a second. I'm going to draw this off to the side. X-intercepts are points on the graph at which my y is equal to 0. So I'm going to take my original and I'm going to set it equal to 0. So to solve this guy, we know we're going to get rid of the bottom because when we have fractions, we know that fractions mean division. And to undo division, we multiply, but then we're going to have something times 0, which is just 0. So essentially here, I just take that top and I set it equal to 0. So I add over the 18, divide by 2, I get x squared is equal to 9. So I get x is equal to plus or minus 3. Now, this is an intercept, so it's a physical point. Well, we don't need to plug it in because we already said it's going to be 0. So I have a point at negative 3, 0, and I have a point at 3, 0. Now, we're going to want to take a look at these later. So on a different color, I'm going to highlight them a little bit. I'm going to highlight, that's what I'm talking about, because I'm going to reference that later. I don't know if I'm going to do purple. I think I might do a different color. Let's do something I haven't used yet. Let's do this blue. I'm going to highlight that I need it later. We are going to use my first and second derivatives later, but we can just scroll back up for that. This is something specific I'm going to use in that chart. Okay, so then number 4. I'm going to look for the y-intercept. And again, if you think about that logically, that's where my x's are going to be 0. Because anywhere on there, intercept is where it hits on the y-axis. So I'm going to take my original and I'm going to let x be 0. So I have 2 times 0 squared minus 18 over 0 squared minus 4. Which is essentially negative 18 over 4, which is 4.5. So I have a point at 0, 4.5, or 4.5. Well, how do I know it's there? Well, I plugged in 0 to get that 4.5. If you can never remember what your points are going to be in these two, think logically. X-intercept, where does it sit on the x-axis? Well, there's no 0. Y is always 0 there, so it's just going to be 0. Conversely, the y-intercept, that's where x is always 0, so your x value should be 0. Alright, so we've got, what's that, 4? So our number 5. We're going to take a look at vertical asymptotes. Now, vertical asymptotes happen when the bottom is 0. So I'm going to take my denominator. And I don't want that to be 0. So I'm going to solve to see where that would be 0. Well, we've seen this one often enough. We should see that we're going to have 0 when x is plus or minus 2. And that's going to play a role later, so I'm going to highlight that. So all these little tricks and stuff that I'm saying out loud, y is 0 here, x is 0 here, you can write that down. Vertical asymptote, bottom 0. Make notes of that for yourself in your notes, so that way you can reference it in your understanding where I'm pulling all this information from. 6 is my horizontal asymptote, and that's where I divide stuff out. So I have my original problem of 2x squared minus 18 over x squared minus 4, and since I'm going to take, here, let me scroll up for a second. Since I'm going to take and divide by the biggest x on the denominator, I'm going to divide by x squared. So I have 2x squared minus 18 divided by x squared. over x squared minus 4 over x squared. That will reduce down to 2 minus 18 over x squared over 1 minus 4 over x squared. And this is taking the limit of it. Yes, I know I didn't write the word limit, but it's going to take up more space. Be aware that we're doing the limit here. So it's going to give me 2 over 1, which is going to be 2. So I have a horizontal asymptote at y is 2. And I don't want to do that in purple. I want to highlight that in my pretty fun blue color. These next couple might be in a little bit different order just because I did it based on what I already had on the homework. Remember, I took some of this homework from Mrs. Hills. Shh, don't tell anyone. I have her permission, don't worry. So I did it based on that, so it'd be in your order. So when you go to do it on your homework tonight, it'll fall on the same line. I know it might be a little different off than your chart, but at this point, you just need to have everything. It doesn't necessarily matter what order you do it all in. So next thing I have is my critical points. Oh, I forgot my domain. I lied. So number 7. 7 is my domain. And that's going to be whatever I got for my vertical asymptote. So that one's going to be the x cannot be equal to plus or minus 2. Otherwise, we can plug in any number here. Now, and I've already talked about the x plus or minus, x can't be equal to plus minus 2, so I'm not going to circle it again. Now I'm going to go ahead and talk about my number 8, which is the critical point and point of inflection. But we're going to do it each at a time. So critical point is when the first derivative is 0. So that was 20x over x squared minus 4 squared. So then that gives me 20x is 0. So a critical point is 0. And typically we plug the 0 back in and solve for it, but we already know above that it's 4.5. We've already plugged in 0, and I don't want to do that. If I scroll up, we already got that up here with my y-intercept, so I'm not going to highlight it again because I've already talked about it. I just know that my critical point is going to be my y-intercept. So the next is my point of interest, point of inflection. Person of interest is usually what you see when you see POI. And that is when you take your second derivative and set it equal to 0. So I have negative 60x squared minus 80 over x squared minus 4 quantity cubed. So negative 60x squared minus 80 is 0. I add over my 80, divide by a negative 60, and I get negative 80 over 60. Now because that, in a different color, let's do this green, highlight it, has a negative sign, I go and try and take the square root. I can't take the square root of a negative sign. It's not possible. So there's no points of inflection. And that happens sometimes. Okay, so this is, like that was 8 and 9. That was 8. 9 is the chart. 10 is the results. So now what we're going to do is we're going to use 9/10 together. /11. Because I'm going to make the chart, and then from the chart I'm going to go ahead and graph it. So this is the chart, the results, and the graph kind of all together. So to do the chart, I need to take a look at what numbers were important to me. So I'm going to go back and look at whatever I circled. And I'm going to look at the x values. So my smallest x so far is a negative 3, and the biggest is a 3. Then I have 0, I have plus or minus 2, and I have 2. So when I do my chart, I'm going to make some lines. You know, they're not really even. They don't necessarily need to be even. The first section is going to be the chart, the different intervals. The next section is going to be what happens in the first derivative. This one's going to be the second derivative. And this guy's going to be the results. And I don't know why I have that extra line then if I don't really need that. So I'm going to delete that. Go away. I don't like you. So we have seen our charts before look like this. Negative infinity approaches x is less than 0. And we pick numbers. So we're going to do, and then we have, say, 0 is less than x is less than 2. And if 2 is less than x is less than infinity. We're going to take this part that we did, and we're going to make it vertical. And we're going to base it on, again, our x values that we have from smallest to biggest, because we like to be mathematically correct. And so the smallest x value I have is -3. So before I approach 0, I want to see what happens to the left side of it. So I have negative infinity. It's less than x. It's less than -3. I like to keep my thoughts straight, so I draw a straight line. You don't need the straight line if you don't need to. I need it to help me actually keep my thoughts straight. Next is I want to see what happens at -3. The next value, the next smallest value, I believe is -2. So I want to see what happens between -3 and -2. And then I want to see what happens at -2. And then my next one I think is 0. So I want to see what happens between -2 and 0. And then I want to talk about what happens at 0. And then the next one is 2. So I want to see what happens between 0 and 2. What happens at 2? What happens between 2 and 3? And then what happens at 3? And then finally, what happens after 3? So, this is quite large. I understand it is very large. This part is going to be probably one of the biggest sections on all of your notes and all of your homeworks and your review and your test. But it allows us to see every single piece that's going on in my graph. So then I know some stuff that is already going to happen at some of these points. So for example, at -3, back up, I'm going to have my intercept. So I'm going to have a point there at -3, 0. So I don't really care what happens in my first and second derivative. I'm going to switch colors here. I don't really care. I'm going to use that blue though. So yeah. I don't really care. I know I'm going to have a point at -3, 0. And at -2, that's where I have my vertical asymptote. Or my does not exist because of my vertical asymptote. Snaps. I wrote that on the wrong line. And then at 0, I now have a point at 0, 4.5. At 2, again, I don't exist because I have a vertical asymptote. At 3, I don't care what happens at my first and second derivatives because I already know what's going to go on there. So the only part of the chart that I really don't know is what happens in between and on the other sides. So I'm going to do a trick that I find to be super easy. The last time I showed it to you guys, you weren't too fond of it and liked doing it the normal way because you thought it was faster. However you want to do it is fine. I just think that saving it is easier. So I'm going to take something smaller than 3, so say -4. And in my calculator, I'm going to hit -4. I need to see myself so I can make sure I'm doing this right. So I'm going to hit -4. We're going to store it as x. I'm doing this backwards. So you should see this. And then you're going to hit enter. So now you see -4. So anytime you hit x and you hit enter, you get -4. And every time you change your x stored, it's not going to be -4. It'll be whatever you change it to. So I want to plug in -4 into my original function. So my original function is 20x, not my original function, my first derivative. So I'm going to have 20x divided by x squared minus 4 squared. So because I've stored 4 in there for x already, I can hit my x and not have to plug in -4 every time. That's why I like the storing part. And that gives me a negative. Gives me a negative there. So on my first derivative, I'm going to put a negative sign. Or if you want to write, we're used to writing increase or d, so we can put a d for decrease. And then I still have -4 in here, and I want to plug that into my second derivative. And so I'm just going to go ahead and plug in my second derivative. So -60x squared minus 80 divided by x squared minus 4 quantity cubed. And if you take a look for a second as to how I wrote that, I can write that all at once. I put parentheses around the top and the denominator and separate it with a fraction sign or division sign. And I go ahead and hit enter. And it gives me again another negative, which we always said was down. So I'm going to be decreasing and I'm going to be down. Okay, so now I want to see what happens between -3 and -2. So let's do -2.5. So I'm going to take -2.5 and I'm going to store it as my x. I'm going to hit enter. So it's stored. So then what I'm going to do is I want to recall, or I want to bring up what I did in the past, because I already have my function here for my first derivative and my second derivative. So I'm going to hit my second button. I'm going to hit entry. And it brings up me trying to restore it, or me trying to store -2. And I don't want that. I want something before that. So I'm going to hit second again, enter again, and I see my second derivative. But I want my first derivative first. So I'm going to hit second and enter again. And hey, look, that's my first derivative. So in this case, I want to plug in that -2 in my first derivative. So since that's what I want, I'm going to hit enter. And it gives me a negative. So I'm going to be decreasing here. And then I want to go back and I want to do my first derivative, or I'm going to go back and do my second derivative. So again, I'm going to recall my second derivative. So I'm going to hit second entry, second entry, second entry. Hey, look, now it's saying, do you want the second derivative you already stored? And since you have up here, your x is -2.5, that's what we want. So we're going to hit enter. And it gives me another negative. So I'm going to be down. So I'm going to be decreasing and I'm going to be down. Okay. Now let's see what happens between -2 and 0. So let's store -1. So I have stored -1. Again, I'm going to do my second entry until I bring up my first derivative. Second entry, nope. Second entry, that's second derivative. I want my first one first. Hey, there it is. And it's again saying, do you want to do this with your x of 1, of -1? Yep. So I get another d. I'm decreasing. So I want to do again for my, so I got to find my fingers. I want to do it again for my first derivative. So second entry, second entry. Nope, still not it. Hey, there it is. And I get a positive. So in our second derivative, when we said positive, we said up. So we're going to be down and we're going to be concave up. Okay, next thing I do is between 0 and 2. So this time I'm going to store +1. So again, I hit 1 STOX. So I have stored, oops, I accidentally hit a button. Go back. I have stored x as 1. And I'm going to do my recalling again. That's my second derivative. Oh, my first derivative. There it is. So I'm going to plug in 1 this time. And I get a positive. So we're going to be increasing. And then I'm going to second entry, second entry again, second entry. Hey, there's my second derivative. Enter. Oops. So we are up. So we are increasing and we are up. And by up, I mean concave up. I wrote that in the wrong line, didn't I? Aha! Sorry about that, guys. Hold on. Let me fix that. We are increasing and we are concave up. So we are increasing concave up. Sorry, my apologies. I was like, 1 wasn't between 2 and 3. That doesn't make sense. So next I'm going to go ahead and find something between 2 and 3. 2.5. So 2.5 STORX. Second store, or is it second store, second entry, second entry. That's my second derivative, so I want my first derivative. There it is. I get a positive, so we're increase again. So I probably could have left that either, but I wanted to be sure. Second entry, second entry, second entry. Hey, there it is. Negative, so we are concave down in this case. So we're increasing, but concave down. And then, whew, my last one, something bigger than 3, which I'm going to just pick 4 again. So 4 stores x. So second entry, second entry. That's my second derivative. There's my first derivative. We are positive, so we're increasing. And then I want my second derivative. There he is. I'm negative, so I am down. So I'm increasing, but so whew, now we're going to make our graph. Too many. Didn't want to respond. I didn't think I was thinking. So I'm going to go ahead and do my outline in black. I know we have some stuff going on at negative and positive 3, so I need at least 3 of here. 1, 2, 3. 1, 2, 3. Trying to make them even. I know I have a vertical asymptote when y is 1. Vertical. I know I have a horizontal asymptote when y is 1, so I need at least 1 in each direction. So I'm going to go ahead and put in my points that I have and asymptotes. So I've got a point at negative 3, 0. I've got a point at, I've got an asymptote at negative 2. So dotted lines, we can't go past there. I've got a point at 0. Oop, I forgot I have to put my 4.5 on there. So 1, 2, 3, 4. It's a little bit bigger. I've got my point at 0, 4.5. I have another asymptote when x is 2. And I have another x intercept when x is 3. So all I've done there is put in the stuff we started with. So let's go ahead and look at what my chart is telling me. So if I scroll back up, when we're approaching negative 3, we're going to be down, we're going to be decreasing, which means we're going to go left to right down, and we're going to be concave down. So we're going to be looking like this. And then if you also notice, because we're still going to be, I haven't hit an asymptote yet, so I don't necessarily want to stop. I'm also going to be decreasing down. So, I also hit backtrack. I forgot my horizontal asymptote. So my graph is going to look like that on that first part, because I was decreasing and I was down. Decreasing left to right is getting smaller. as your x's get smaller, your y's get smaller, and we're concave down, so concave down's upside down parabola. So let's take a look at what happens when we approach 0. We're decreasing, but we're going to be concave up. So when we're decreasing but concave up, we're going to kind of look like a parabola. And then on the other side, we're going to be increasing. We're going to be increasing in concave up. So it's going to look like a parabola here in the middle. And that's going to be centered at my y-axis, or my y-intercept. Next part is going to be my increasing down. So we're going to be increasing, but we're going to be concave down. And again, we're going to be increasing and concave down. So we're going to be increasing and concave down. So there we go, ladies and gentlemen. We have graphed our first problem. Woo! I'm going to go ahead and stop the video so you guys can catch a break and take a pause, and then come back and finish the other part.